Hi everyone. So for today's class, we're going to look at composite function. Now, composite function can be viewed as working one function and combining it with another function. So it's unlike multiplying or dividing functions, but it's actually combining two functions. All right. So we can think about it as first doing the first function, then do another function. All right. So that is basically what composite function means. Now, let's look at this explanation to see. Now, we have two functions here, fx, which is equal to x plus 5, and we have gx, which is equal to 2x. Now, what if I want to find the composite function of fx and gx? Now, in this case, I will call it f gx. So first what we will do is we will put g, all right, as a sort of like an input, all right? So we can take g as an input, and the whole g function will replace the x value or the input placeholder. In this case, for fx, your placeholder is actually x. So we're going to replace that x placeholder with the entire gx function. All right, so in this case, fgx would basically means 2x plus 5. Basically, I replace the whole placeholder of x with the function 2x into that. All right, and simplify that. This is 2x plus 5. Okay, so basically that's a composite function. Now we can try another example. If we do g fx, so this means that our placeholder here is 2x, but this x will be replaced entirely by the function fx. In this case, is x plus 5. Right? And if we simplify that, it's 2x plus 10. Okay, so basically that's the whole process of how you find composite function. Now don't worry, we will have more explanation and examples later on. All right, now there are some rules with regards to functions that you have, or composite function that you have to know. First, if you want to find fgx, which is a composite of f and g, now it only exists if the condition is that the range of g must be a subset of the domain of f. All right, must be a subset of the domain of f. Meaning to say, let's say my range has 1, 2, 3, all right, and my domain is 1, 2, 3, 4, 5, then yes, fg will exist because 1, 2, 3 is a subset of 1, 2, 3, 4, 5, is part of it. Now, what if my range have, let's say, 6, and my domain doesn't have 6? Then cannot. You can't have a fg composite function because 6 is a range value of g that doesn't exist as part of the domain of f. Okay? So we have to be very clear whether this exists first or not before we find the composite function. And do take note that fgx is not equal to gfx. It's not a multiplication. All right? It's not a multiplication. So have to remember they don't mean the same thing. Okay? All right, let's look at a few examples to help you to understand how to do composite function as well as how we will find domain and range of composite functions, yeah? All right, let's look at this example. So I have fx, 2x minus 1 with the domain where x belongs to all the real values, and I have gx equals to x squared plus 5 with the domain of x belonging to all real values. So in this case, I guess my range for fx will be probably also all real values, right? And I think similarly for range of gx, it is also all real values. Yeah, yeah, all real values, but probably positive, okay? Because whatever you square becomes positive. You add 5, it's still positive. So positive real numbers, okay? All right, so basically that. So let's look at fgx. How do you find the composite of fgx? Fgx. So we want to first analyze whether or not the range of gx is a subset of the domain of f, and it is, right? Because the range of gx, which is all positive real values, is a smaller part of the entire fx domain, which is all real values, including positive and negative. So yes, composite function will exist in this situation. All right, so we're going to put gx, all right, going to replace it under the placeholder of the x in the 2x minus 1. So we're going to write it as 2 bracket, like a placeholder, minus 1. That's my fx function. The x is being replaced by my gx function, so x squared plus 5. It replaces the placeholder. Simplify it, we have 2x squared plus 10 minus 1, and we have 2x plus 9. Okay, 2x squared plus 9. All right, so that's how I find my fgx function. All right, let's do the next one. Gfx. Gfx, let's see if it exists or not. My range of my fx belongs to all real value. My domain of my gx is all real value, so all okay, everything matches up, that's fine. So gfx can be found. So in this case, my g function will be x squared plus 5, right? So I put the x as like a placeholder. I'm going to replace the placeholder with the entire fx function. In this case, it's 2x minus 1. All right. So I'm going to expand this. So this will be 4x squared minus 4x plus 1 plus 5. Simplify it. We will have minus 4x plus 6. Okay. So that's how I find my gfx function. All right. And again, it's a composite function. Now, the next part is the f square x function. Now, f square x really just means ff. X. Yeah, you're composing the fx function by itself. All right, so we'll have 2. The placeholder will be the x minus 1, and what we're going to place in the placeholder will be 2x minus 1 itself. All right, so 4x minus 2 minus 1, which is 4x minus 3. All right, so this is how you find the composite function of fgx, gfx, and ffx. All right. Okay, so I hope that's all clear on how to find it. Now, the next example we're going to have is a bit trickier. We are actually using the idea of the composite function and the rules to find out the domain and range of the composite function fgx itself. All right, so this part here, I would suggest if you are quite confused on my explanation, you can always pause it and rewatch it over and over again until you understand. Now, the first thing I want to highlight to you guys is this, before we move on to this question, is that the rule we mentioned earlier on, for fgx to exist, right, the range of g must be a subset of the domain of f. Yeah, that means whatever g output it's going to have, it must be part of the domain of f. If it's not, then the composite function does not exist. All right, so let's remember this rule and let's analyze this question to see how we find the domain and range of fgx. Okay, so let's look at what is gx first. Now gx is 8 minus x over 2, where the domain x belongs to all real values and x has to be more than 4. All right, x has to be more than 4. Okay, so the next part is, how do we understand that? How do we understand that fact that x must be more than 4? All right, if x must be more than 4, will that complicate the relationship with the fx later on? Does this rule still hold? All right, so that is what we want to actually analyze. Okay, and that's very, very important. Okay, so let's look at the function of f as well. All right, fx is equal to x squared plus 4, where x belongs to all real values and x must be less than 0 at the same time. Okay, so what's going on here? We have to look at gx itself, and we have to understand very importantly that since the function of fx is defined only by the negative value, which means that x is less than 0. Now, for fx to exist, for fgx to exist or to be valid, all right, the output, the range of your gx must exist or must be a subset of the domain of your fx. Must be a domain of your fx. Okay? And since your domain is actually x is less than 0, so this is the overriding condition for the domain of fx. It has to be less than 0. So which means that your range of gx has to be less than 0. Has to be less than 0 for it to exist. If it's not less than 0, it won't exist. Okay, so then what does that lead us to? If that is true, that means our gx function, 8 minus x over 2, all right, has to be less than 0 in order to find what is the x value that allows the gx to be true and then become a part of the composite function of fgx. All right, so we're going to simplify that. It will be less than x over 2, so x must be more than 16. Okay, so this is very important. For the domain to exist, then we must say that therefore x must be more than 16 for fgx to exist or to be valid. If not, for example, if we choose any other value other than not value smaller than 16, let's say 10 for example. If we have 10, then gx will be more than 0, which will not fulfill our condition when we say that gx, a range of gx has to be less than 0. Okay, so this is very, very important. All right, next part. Now that we have kind of like the domain, we can kind of understand what's going on. What will be the actual domain itself? Now, we have two things to consider. All right, it says that g has to be more than 4 and gx has to be more than 16. So which one is valid? Which one is valid? Now, the question is, we want to only choose the part where both the domain kind of intersect. All right, so you think about it as a number line. 4 is here, 16 is here. Initially, the domain of gx is 4 to infinity. And for it to exist as a composite function, it has to be from 16 and above. Okay, so what we will do is we only choose the part where it intersect, right? In this case, therefore, to ensure that fgx is valid, all right, we need to ensure that therefore the x has to be more than 16 for it to be true. Right? If it's less than 16, again, it's not going to be true, so we cannot have that. All right, so that's the domain of fgx. Very important. Okay, now that we know the domain of fgx, let's talk about the range. All right, so before we can find the range, let's find fgx first. Then we kind of know how it looks like. All right, let's compose them together. So fgx, that means 8 minus x squared will be part of the replacement of the placeholder of x squared. So 8 minus x over 2 square plus 4. Okay, plus 4. And we know the domain is that x has to be more than 16. So then what is the range? Now, there is no magical way to find a range. Like I can't tell you, okay, do this, you get a range. You have to look at the situation. Now, this is a quadratic function. Think about it. It looks like a x squared plus 4, right? So this is a quadratic function. In fact, this is in the vertex form itself. So what we will do is that we will find the, we actually don't really need to find. We know that if this is a vertex form, then 4 will be your point of the vertex itself. All right, and that's pretty important. Okay, so what's going to happen is that when we were to expand this, this is going to be a U-shaped graph. Okay, don't really need to know what the x is, but we know that the y value here has to be 4. Okay, this is the minimum y value. and it keeps going further up from there itself. As x increases, it just keeps going up. All right? So, then you say, oh, what happens if the x value is not part of the 16? Or is less than 16 and so on? Okay, so probably we need to just verify, is it true? So we're going to equate these 8 minus x squared equals 0 and work out that x must be 16 itself. That means this coordinate here is 16, 4. So now it's very clear. So at 16, 4, that's where your minimum happens. But since x cannot be 16 itself, then our range cannot be exactly 4 itself. It has to be above 4. So therefore, the range of f g x has to be more than 4. Okay? So now we have it. The domain and the range of f g x. Okay. So I hope it is clear. All right, how you find the domain and range of a function. Now, I know this can be quite confusing, so do pause the video and rewatch it over and over again until you understand this concept. All right, so I'll end here. Have a good one. Cheers.